Hello, madam. Hello, sir. This is Dharnav Ganesh. Hall ticket number 21955 A0302. Third year, fifth semester, Mechanical Engineering, IRE College. Now I am going to present my concept video topic on ceramic applications. What is ceramic? What is ceramic? Ceramic is a hard, brittle, heat resistant, and corrosion resistance. A ceramic is an inorganic, non-metallic solid mainly sorry, mainly based on oxide, nitride, boride, and carbide, and they're shaped and then fixed at high temperature resistant. Ceramic is used almost everywhere, like in kitchens, cookware, pottery, bricks, pipes, etc. Many ceramics contain a mixture of ionic and covalent bonds between them. That's why they exist in crystalline and semi-crystalline and vitreous form. So here the ceramic is a hard and brittle particle. It is in brittle nature. Brittle nothing but it is easily breakable, suddenly breakable. So and it is also a hard in the sense it has high strength, but it is in a brittle nature, and also it is a heat resistant. Heat resistant nothing but it won't melt by adding of heat. It withstand as a heat, and also it is in corrosion resistant because it is non-metal, no. So there is no chance to form a corrosion by oxide and atmospheric humidity. A serum, and also it is an organic and non-metallic, and also it is mostly based on the oxide, nitride, boride, or carbide that are shaped, and also by using of oxide, nitride, and boride, carbide, these ceramics are going to be manufactured, and also these are heated at the high temperature, and it is resistant. And these ceramics are mostly using in kitchenware, bathroomware, bricks and poetry and pickle storages and etc. And these mixture of ceramics are that is covalent bond, ionic bond, and also the bonds between them. And also these ceramic exist in crystalline, semi-crystalline vitreous form. And the image is one of the example of ceramic materials. Nowadays, any beside we can able to see the ceramic materials and the ceramics material sellers. So that much less cost, and it has a high. It is an hard material and it is a brittle material. So the ceramics nowadays most popular basic materials, basic items. Properties of ceramics. Ceramics have high hardness. Just now we discussed the point high hardness, and brittle. It is also discussed, and poor toughness. They have high melting point. They have pure electrical and thermal conductivity. Have low ductility. They have modulus of electricity. They have high compression strength. They have optical transparency to variety wavelengths. High hardness nothing but it can able to withstand more weight, and also brittle in nature means it won't withstand sudden forces. If suppose it is an brittle it is a ceramic, if it is fallen suddenly from free air to the tile upon the tile, it may be suddenly breakable because of it is because of a brittle nature of the ceramic, and it have a pure electrical and thermal conductivity because it is an sorry, uh, ceramic have poor electrical and thermal conductivity. Ceramic has a poor electrical and thermal conductivity. It won't allows the current to flow, so it resists the flow of current or electricity or thermal conductivity. So it is act as an insulator. Thermal ceramic act as an insulator and have low ductility. Low ductility in the sense it won't deform its shapes once it is manufactured. So it is means for ductile. Tensile. There is no formation of tensile strengths. Applications of ceramics. Silicon carbide and tungsten carbides are technically ceramics that are used in body armor, wear plates, mining, machine components due to high absorption resistance. Uranium oxide UO2 is a ceramic that is used as a nuclear reactor fuel. Nowadays, if in mostly fields, in most fields, ceramic materials are going to be used. In a few examples are mining and machine components and high absorption resistance. And also not only in those fields, and even in uranium oxide, ceramic is used as a nuclear reactor fuel. Zirconia is a ceramic that is used to make ceramic knife blades, gems, fuel cells, and oxygen sensors. Barium titanate is a ceramic that is used to make heating elements, capacitors, translators, and data storage elements. Sterlite is a ceramic that is used as a electrical insulator. Barium titanate, capacitors, transducers, data storage elements. So, and also electrical insulators. Just now we discussed. When the point it is an thermal, at the point we discussed, no, ceramic, even ceramic is going to be act as a electrical insulator. Zirconia is a ceramic that is used to make knife, blades, and jam fuels and oxygen sensors, and also not only storage elements, data storage elements, capacitors, transducers, and also in electrical insulator. Classification of ceramics. Based on the composition of oxidized ceramics contain oxidizer fibers which include a combination of zirconium dioxide, aluminum trioxide, and titanium dioxide. The oxide fibers helps a ceramics to withstand oxidation and provide high strength and reinforcement. Classification based on the composition and oxide fibers and zirconium dioxide and also aluminum trioxide, titanium dioxide. These all withstand and also withstand the oxidation and so provide the strength and reinforcements by in oxide ceramics. Alumina ceramics. Alumina ceramics have high strength, have high chemical resistance, increased strength, and high temperature resistance. Alumina ceramics can be manufactured from its powder corresponding then fired over heat. Beryllium oxide ceramics. Beryllium oxide ceramics have good thermal conductivity, high insulation, low dielectric constant, low medium loss, good process adaptability. Beryllium dioxide ceramics are used as a component in glass, and that glass is used to make X-ray tubes which are used for medical purpose. First one, aluminum siroxide. That is manufactured from the powder form, then corresponding it and then fired overheated. Beryllium beryllium oxide ceramics have a good thermal conductivity, high insulation, dielectric constant, low medium loss, and good process adaptability. Beryllium oxide ceramics are used as a component in glass, and that glass is used to make X-ray tubes and which are used for medical purpose. Non-oxide ceramics. Non-oxide ceramics offer a great replacement to oxide ceramics because oxide ceramics can't be used in extreme environment and can be bear heavy loads. Non-oxide overcomes all these limitations of oxide ceramics because they have high corrosion resistance, hardness, and oxidation resistance. They even don't degrade till 24 degrees temperature. Following on most common types of non-oxide ceramics. These non-oxide ceramics can bear, these can't bear heavy loads. Can't bear in nothing in the sense it won't withstand for heavy loads. It only can withstand for only few amount of load, and also it have high corrosion resistance. The non-oxide have high corrosion resistance and hardness and oxidation resistance, and have even don't degrade 2400 degrees Celsius temperature. And these non-oxidized ceramics are most commonly types of non-ceramics types. Silicon nitrate ceramics. Silicon nitrate ceramics have low density, high fracture toughness, good flexural strength, and excellent thermal shock resistance. Silicon nitrate ceramics are used for rotating bearing balls, and rollers, cutting tools, moving engine parts, turbine blades, and weld positioners. Silicon carbide ceramics. Silicon carbide ceramics are lighter and harder than other ceramics and resist to acid. They have low thermal expansion, high conductivity, and are chemically stable. Silicon, and also the slide, it's a silicon nitride, high fracture toughness and good fluctuation and external thermal, and it have an thermal shock resistance, and it also used for rotating bearing balls and rollers, and even it is used for turbine blades, and also silicon carbide ceramics are lighter and harder than other ceramic resistant to the acids. Composite ceramics. Composite ceramics is made up of two or more constituent materials with different physical and chemical properties. These materials combine to produce a material having different properties than individual components. Composites have ceramic fibers embedded in the ceramic. Composite nothing but combination of two or more constant materials. And if ceramic means in the case of ceramic, composition of two or more constant materials in this with different physical and chemical properties to make the ceramics known as composite ceramics, and it have ceramic fibers embedded in the ceramic. Fiber reinforced ceramics known as ceramics matrix or mixer fiber component. It is increased toughness, high strength polystyrene structure, Due to their high ability to resist high temperature and resistance, they have used for heat shield systems like burners, flash, flame holders, and hot gas ducts. Fiber reinforcement ceramics. It tells the it is a mixture of uh, ceramic matrix fiber composite. It has and also by after mixing these fiber reinforced ceramics, it can increase the toughness, eye strength, and polycrystalline strength, and also it has an ability to, because of these fiber reinforced ceramics, it has ability to resist high temperature and resist. They are used in heat shield systems like burners and flame holders and gas ducts. Let's revise what we learned in this session. Applications of what is ceramic, properties of ceramic, applications of ceramic, classification of ceramics. In briefly, thank you.